question given is, using the properties of determinant, prove that in the first part the determinant x plus 4, 2x, 2x and so on is equal to 5x plus 4 into 4 minus x whole square. In the second part we have been given the determinant y plus k, y and so on. We have to prove that it is equal to k square into 3y plus k, right? Now to solve these determinants, first of all, taking the left hand side of the determinant given in the first part, that is x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4. We have to prove that this determinant is equal to 5x plus 4 into 4 minus x whole square. Applying the property, C1 is changed to C1 plus C2 plus C3. That is, to the column 1, I am going to add the elements of column 2 and column 3. This is done because on observing the determinant, I see that the sum of the elements in the row 1 or 2 or 3 is equal to 5x plus 4. So applying this property, I am going to get the determinant like this. The elements of the first column to which elements of the second and third columns are added. Right? So this will be equal to 5x plus 4, 5x plus 4, 5x plus 4, 2x, x plus 4, 2x, 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 x plus 4. Right? Now, as you can see here that the column 1 has all the three elements as 5x plus 4. Therefore, taking 5x plus 4 common from C1, I am going to get this as equal to 5x plus 4 times the determinant 1, 1, 1, 2x, x plus 4, 2x, 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 x plus 4. Now, on observing this determinant, I see that the column 1 has all the three elements as equal to 1, right? So, the determinant can be converted into very easy form by making the two elements of a single column, that is the column 1, as equal to 0. So applying R2 is changed to R2 minus R1 and R3 is changed to R3 minus R1. I am going to get this determinant as equal to 5x plus 4, this first row as it is. The second row will be 1 minus 1, x plus 4 minus 2x, 2x minus 2x. 1 minus 1, 2x minus 2x and x plus 4 minus 2x. So on simplifying, I am going to get this as equal to 5x plus 4. This first column will have the elements 1, 0, 0. This 2x, 2x cancels out. So I am going to get this as 2x, 4 minus x, 0, 2x, 0, 4 minus x. Expanding the determinant along C1, I am going to obtain this as equal to 5x plus 4 into 1 time 1 into the determinant obtained by removing the first row and first column, that is 4 minus x, 0, 0, 4 minus x, and plus 0 for the second term and plus 0 for the third term, because 0 into any number is equal to 0. And this on simplifying give me 5x plus 4 into 4 minus x whole square. So this is what we have to prove, and hence the question is proved. So that's how we are going to prove the first part. In the second part, I have been given in left hand side y plus k, y plus k, y plus k. Okay. So applying C1 is changed to C1 plus C2 plus C3. Again, I see here is this, that if I add all the elements of row 1, row 2 and row 3, I get the total as 3y plus k. So this will be equal to y plus k plus y plus y, y k plus y, y plus y plus y k, right? So on simplification, I'm going to get this as 3y plus k, 3y plus k, 3y plus k, and the remaining determinants as it is. Further, I can take 3y plus k common from the first column. So I'm going to obtain this as 3y plus k, 1, 1, 1, and the column 2 and column 3 as it is. Again, the determinant has all the elements as equal to 1 in column 1, so it can be converted into very easy form by making these two elements in the column 1 as equal to 0. So applying R2 is changed to R2 minus R1, and R3 is changed to R3 minus R1. So I'm going to get this as 3y plus k, 1, 1 minus 1, 1 minus 1. Okay, this y as it is, y plus k minus y, y minus y, y minus y, y plus k minus y, right? So on simplifying, I'm going to get this as 1, 0, 0, y k 0, y 0 k. Expanding along the column 1, I'm going to obtain this as 3y plus k into 1 times k 0 0 k, that is the determinant obtained by removing the first row and first column, plus 0 plus 0, because 0 into anything is equal to 0, so the next two terms would be equal to 0. This on simplifying would give me k square, so this will be equal to 3y plus k into k square, and hence the question is proved. So this is how we are going to prove the second part.